Welcome to today's webinar. We're going to go ahead and get started. I'm Kevin Holbrook from CAD Dimensions. I'm one of our technical solution specialists in charged in learning the softwares that you see on a daily basis. Today's session, we're going to talk about a new product line from SOLIDWORKS that's complementary to the SOLIDWORKS tools that we have today, focusing specifically on conceptual design and the ability to share ideas with outside groups or internal groups within your organization. We can't really talk about this product called SOLIDWORKS Conceptual Designer without giving you a background on the platform that the software is built upon. So SOLIDWORKS has a parent company called Dassault Systems that develops a platform called 3D Experience. So what is 3D Experience? Well, 3D Experience is a business platform. It's intended to allow companies to develop softwares that give a delightful experience for their customers or consumers. So think of it this way. Companies are building apps that run on the 3D Experience platform. Now, the reason this is important today is because SOLIDWORKS Conceptual Designer runs on the 3D Experience platform. A little bit more about the platform itself. What you're seeing here is something we call the If We Compass. So it's part of the 3D Experience platform. Well, the compass itself and the quadrants in the play button all mean something. Okay? For instance, the right-hand side is all your apps for information intelligence. There's an app called 3D Dashboard, which I'm going to show you here in a minute. The top of the compass is how I would get to my social or collaborative applications. A product called 3D Swim, which is a community-based place to talk about your products or projects. The 3D is where we get to the SOLIDWORKS Conceptual Designer, and then at the bottom we have simulation apps provided by Simulia. Simulation like SOLIDWORKS FEA simulation. Okay. Now, the center of the button provides a 3D experience for your users. The ability to make it interactive, and we'll talk a bit more about that as we introduce the platform a little further. Now, the 3D Experience platform, as I talked about, is a Dassault product. Other companies are developing apps that run on the platform, and just like any platform, it has some out-of-the-box capabilities. The ones I want to point out, the ability to have a single sign-on from anywhere. You're sitting in a coffee shop and you want to get into the platform and check out something on a project. You can log in from a computer using a single login. The ability to do 3D messaging, talk to each other real time. The ability to search for data. So just keep in mind the platform, the 3D Experience platform, has some out-of-the-box capabilities that Conceptual Designer is going to take advantage of. Now, when you look at an application that's built on the platform, there's a lot of things that come as part of the interface for the app that are the same regardless of which app you're using. For instance, here you can see in the left-hand corner of my 3D Experience app, here you get a compass where I can get access to my apps, and I'm going to show this live here in just a moment. In the center of the screen, we have the ability to search any of our data, just like we have the ability to have custom properties. In SOLIDWORKS files, we have something on the platform called tags, 6W tags, tagging who, what, why, when, where, the ability to search and tag content. Off to the top right-hand side, you'll see multiple menus. One is the Me menu. This is the menu where I put in information about me, what my preferences are, what my roles are in the organization. I have a menu to create content, a menu to share content, and the ability to go home and get to my base. At the bottom of many of these programs, they have something called the action bar, which I'm going to show you a little bit more as we get into SOLIDWORKS Conceptual Designer. But this is the base for any app built on the 3D Experience platform. So let's go ahead and just take a look at my 3D Experience platform. So I'm logged into a web address. I've provided my credentials. We mentioned the single sign-on. And I'm in an application, an app on the platform called 3D Dashboard. Now this is not obviously Conceptual Designer, but the interface, because it's built on the platform, looks the same. I have the compass, I have the search, I have the tags, and I have my menus, like all programs built on 3D Experience do have. If I wanted to switch apps, all I have to do is go to the compass, and the compass is physically live. It's like a button in your software. So one app I might use is something called 3D Swim, and you'll see this when we get into Conceptual Designer presentations. 3D Swim is a swim community. It means see what you mean. It's a way of having a community of users talk about product or projects. Now those users can be internal to your organization, but this is where you'll also get vendors and outside stakeholders involved. And you'll see that a little bit in the presentation. So here's an example of a swim community where we're talking about a product that we're designing, and we're looking at different variations of the design in a community. So this will come up a little bit later. What I really wanted to point out here is just the whole idea that apps are built on 3D Experience, and the 3D Experience platform is very similar in each app that you work with. Okay? So let's go back to my PowerPoint here for a moment. So the apps that we're dealing with specifically on the SOLIDWORKS end, we're going to collaborate with 3D Swim, with the dashboard that I showed you initially. But we're going to focus today on SOLIDWORKS Conceptual Designer, which is the first 3D CAD app for the 3D Experience platform. Okay? A little bit about the typical process, the design process, as it relates to SOLIDWORKS today. SOLIDWORKS has tended to really focus on the later stages, enabling the detailed design of 3D models, 3D drawings, getting them ready for manufacturing and production. So that's kind of where our current SOLIDWORKS sits today. But what about the steps that happen before you actually create production 3D models and drawings? Okay, this is where Conceptual Designer is going to be able to help. When you have that concept phase within your process. Now, talking to our existing users, we've seen a wide variety of tools for concept design. We've seen napkin sketches, we've seen whiteboards, we've seen physical mock-ups, and that's really what led to SOLIDWORKS bringing this tool to the market. There's a gap there. There's a hole. This concept design phase is different. People work differently. Okay, they need to move differently. It needs to be less restrictive. So the question to you, and this is hypothetical, is what do you do before you get to SOLIDWORKS? When you're talking about concepts of your designs, what do you do? And that's why we're here today. So the new design tool is really a complementary tool for SOLIDWORKS users. And I want to clarify what we mean by complementary. It's to be used in that early stage, but it's also going to allow you to move data from Conceptual Designer to SOLIDWORKS. Now, the software was built on 4 themes. The first theme, and this is what customers told us, is they spend 31% of their project time on the conceptual phase. Okay? We needed a tool that had to allow us to work conceptually. Okay? They needed to make a tool also that could overcome all the CAD rules that we have, right? We're working in SolidWorks and we got to build in all this design intent and the rules, and really in the R&D phase, you don't need that. You're working conceptually. You need to work quick without the rules. So we need it to be instinctive. We need it to work the way I want to work in an R&D phase. Okay. We also wanted to ensure that we could overcome the problems with communication. Now think about this. If you're R&D and you're working on product development, you have stakeholders sometimes throughout the world, sometimes your vendors that are located in many different places. How do you bring everyone together to a single environment to collaborate? So one of the reasons for a new design tool is you needed to make it social. You need to overcome the communication barrier. When working with others, we also wanted to allow designers to think about their ideas, not managing the files. Equate this to SolidWorks for a moment. When you're working in the phase where you're refining your 3D model, there's a lot of management of files that goes into that. Whether you're using EPDM or just using Windows, you have to think about references and relationships and where you store things. Well, in the R&D phase, I don't want to think about that. So what we want is to make it easy to manage that conceptual data. We want it to be connected. We want to always be connected to that data regardless. So these are the pillars that we're building this new tool on. Now, what we're going to cover today, we're going to see all 4 pillars of conceptual design in action. We're going to create a 55-gallon barrel lift and tip machine. So the scenario is this. We're working with a customer to create a new mechanical product. The requirements have been posted to a design community. You see this little video here? This is somebody in the organization going to the swim community to find information. Okay, you can access this information from anywhere, on a tablet, on a mobile device. We will return to our community during the project to check in. At the end, we will need to present back to the customer our best idea. And that's kind of our goal today. So the steps for today's project are this. First, we're going to generate the ideas for the R&D product. We then need to work with the team and the customer to select the best design. Okay, we need people involved to see what the best concept happens to be and make a decision to move forward. We then want to focus in and turn the design into a 3D model. Again, it's still R&D phase, but we wanted a 3D model. And then we want to partner with our colleagues to get his assistance with part of the structure. So part of this is working together, collaborating on the concepts. And then finally, we want to refine the details to round out the conceptual model. One thing we want to think of and focus on as we're going through this entire process is, will this work? That's really what we're trying to answer here in this R&D phase of a process, the conceptual side, is will this product work? Not only do we got to put it to paper, but we got to understand the inner workings of this. So here's the first example. Let's say our customer has provided us with a napkin sketch. I need to transfer this idea from the napkin sketch into a digital platform, combining some existing geometry and then simulate the motion to check the feasibility of the design. I need an environment where I can start to capture and evaluate ideas for this mechanism.
You can think of Mechanical Conceptual as a digital version of an engineering notebook or whiteboard. However, in Mechanical Conceptual, we can work with all kinds of content, 2D sketches, existing 3D models, even hand-drawn sketches or photos. To design the retrofit mechanism for this barrel lifter, we'll begin by sketching a 2D mechanism over top of our customer's rough hand sketch. Sketching in Mechanical Conceptual is fast and easy. Familiar drawing tools are right at my fingertips. As I draw, dimensions are automatically suggested. Sketches are grouped into objects which behave like individual components. I don't have to fully define each object for it to behave properly, which means my screen is free from a lot of dimensional clutter. Sketch relations act like mates, so my concept sketch is really a 2D version of a mechanical assembly. Clicking on a sketch entity automatically reveals the object's dimensions, so I can add locating and size information on the fly. Copying and pasting these mounting pads works like you'd expect. I have the option of rotating or mirroring the copies. Adding a few key locating dimensions captures my design intent. The slot tool makes it easy to draw linkages. Just like that, we have a 4-bar parallel linkage mechanism. And now that everything is connected, I can drag the barrel to see the range of motion. It's not tipping the right way, so this might involve some trial and error. Motion simulation tools are built in too, so I can automate the analysis of my mechanism by attaching motors to the linkage. We'll rotate the barrel up by 120 degrees, then back down again over 5 seconds. The motion study also helps me visualize the range of motion with trace paths and area sweeps. Recalling our customer's hand sketch, they've suggested a non-parallel linkage to give the proper tilt behavior. Adjusting this top mounting pad dimension, we can easily modify the mechanism to match the intent of the hand sketch. The 2D motion study automatically recalculates and shows us the new motion path. This combination isn't quite right though, because the barrel is tipping too soon. But if we experiment with some of the dimensions, we can see which dimensions have the greatest effect on the motion path and thus start to zero in on the optimum configuration. As soon as we make any change, the motion study and the trace path updates right away. With a little experimentation, we learn that the mechanism is most sensitive to the position of the mounting post. Sliding the mounting post farther to the right has the effect of smoothing out the tilting motion, which is just what we want. Once I have a design I like, I can use Concept Archives to capture a snapshot of this design iteration. I might have several good ideas, so this way I can record multiple designs and easily return to them if I want to branch off in a different direction.
So in just a few minutes, we were able to digitally capture the initial idea, evaluate the design for its motion profile without investing time right now to go too far down a single path in terms of detailed solid modeling. To see the motion, I didn't have to model every single component. I could even see how the path would update as I changed the sketch dimensions. At each idea, I can store in a single concept archive so I can return to any branch later on. So we're able to quickly capture and evaluate multiple design ideas. Now on to the selection part of our process. It's time to check back in with the team and the customer. It's critical to not only read their feedback, but also to capture the discussion in an accessible way. Remember we talked about the SWIM communities, the See What You Mean? These communities is where we go to see if we get everyone on board to which design we want to use.
Now that I have a working concept, I want to alert my team members. The social collaboration tools are built right into Mechanical Conceptual, so I can create a blog post, add comments, attach files, media, and even capture a screenshot of my current workspace. Once I click Publish, it's visible to everyone who's been invited to the private community. That means my coworkers, suppliers, even customers can review and contribute to the discussion. Community members can access the discussion thread through their browser from any PC, Mac, or mobile device. Fast forwarding a little, we can see multiple concepts have been proposed and posted on the blog, including pictures and video, to help explain the ideas and maintain a history of this rapidly evolving design. The social tools in Mechanical Conceptual are really like a virtual design review that's always accessible. Design ideas are shared and feedback is recorded, all of which helps to streamline collaboration and accelerate the design process.
So when we talk about SWIM communities and cloud-based collaboration, what you want to think about is its ability to help me share ideas with the entire ecosystem and store decision points for review and reuse. Okay, when you're in the R&D phase, you say, do we go this way or do we go that way? These decision points can be captured and talked about in a digital design review. I can invite anyone, customers, subject matter experts, executives, to join in the discussion. So you get other people involved that maybe you wouldn't necessarily get involved in the process. The third stage in our design focus today comes after we review the iterations with the customer through the swim community. I need to go back to my branching point, the point where we've decided to go with a particular method, take the best idea and move it forward, and turn it into 3D parts.
The community content is accessible from within the modeling app as well, and as I scan through the blog post comments, it looks like the team wants to pursue concept number 2. Luckily, along the way, as I'm trying out different design iterations, I saved concept archives of each idea. That way I can quickly go back and retrieve any one of those concepts and branch off in a new direction. With concept number 2, I can see the results of the original motion study that shows a nice smooth lift and tilt movement. This looks like a great spot to move forward. One thing we'll want to include is some mounting points for a hydraulic cylinder that will lift the barrel. I can copy the sketch object from one of the existing pad eyes, rotate it, and then just modify the size and attach it to the existing frame geometry. We'll make one more copy and attach it to this lifting arm. Finally, we'll combine the sketch objects into a single part. This 2D sketch is great for quickly evaluating a mechanism concept, but when we're ready to start bringing our mechanism into 3D, the Sketch to Components feature automates that process by recognizing each sketch object as a unique component in the assembly. Since we already have 3D parts for the barrel, frame, and container, I'll deselect them. To add a 3D extrusion to any object, we just touch and drag. Mechanical Conceptual works in a single modeling environment, which means I don't have to concern myself with traditional CAD rules of keeping track of whether I'm in an assembly, part, or sketch mode. This last lifting arm needs a little special treatment since it will attach to the opposite side of the mounting pad. Right from the extrude dialog, we can choose to start the extrusion from a different face or offset. This means I don't have to create a lot of extra reference geometry on the fly just to get my job done. I also don't have to extrude all the parts at once. In fact, the single modeling environment gives me the flexibility to work interchangeably with parts, assemblies, and even sketches. The sketch relationships established in our 2D mechanism sketch automatically become 3D mates. So the motion study that was defined in 2D is still valid right here in 3D. Well, everything's looking good, but there's still some work to be done to add the supports that will attach the mechanism to the barrel frame. For that, I'm going to get some help from my team.
So we talk about this concept of using archives to take the branched off design, the best idea, and move forward. Sketch to Components, the single modeling environment, makes it easy to go from 2D into 3D. And conceptualizing by mixing 2D and 3D elements makes it an amazing experience. It makes it really easy to manage the CAD assembly constraints. Now, of course, I'm not the only designer with good ideas to share on this project. As with many projects, you get involved with other people. What if I wanted to get some help from a colleague? I'd like to be able to collaborate in real time. So working on the same model at the same time. Let's see how the CoReview functionality helps us to work together, creating more structure for the lifting platform.
It's easy for my coworker Justin to pick up where I left off. Here we see how Justin and Paul can work together on this design. First, Justin contacts Paul through the built-in instant messaging tool. Let's show both of their screens so we can see what each person is doing. Since all our models are stored online, Paul is able to open the same lifting frame model that Justin is working on and never has to wonder if he's got the most recent version. That's way better than emailing zip files back and forth. Justin uses the annotation tools to mark up some suggested changes and shares that 3D snapshot with Paul. The model on Paul's screen rotates into the same view that Justin sees with an overlay of the annotations. Now it's easy for Paul to add a second post and some horizontal supports to the design. First, he copies the existing post. Now he sketches 2 rectangles, applies the appropriate dimensions, and extrudes the supports. Once he saves the model, he sends a chat message back to Justin to have him refresh his screen so he can review the changes. SOLIDWORKS Mechanical Conceptual color codes the models to show Justin what has changed and by whom. If he's happy with the changes, he accepts them, and now everything is up to date. I can pick up where Justin and Paul left off, and I see that we still need to attach the mechanism to the barrel post. We can hide some of these parts and the reference sketch. We'll design a new bracket by sketching on the end of one of these mounting pads. Working in the single modeling environment, I can quickly capture the shape and relationships between parts without really any concern for the assembly structure just yet. A sketch relationship aligns the width of the bracket to the post, and then we just drag the sketch object to extrude the thickness. The bracket is attached to the linkage, but we still haven't connected it to the barrel frame. We can solve that by applying a couple of mates to attach the frame to the new mounting bracket. First, we'll mate the frame flush to the end face of the bracket. Then we just add a mate to lock in the spacing between the bracket and the horizontal support post. Now the linkage and the barrel frame move as a rigid object. Let's show the frame and the container components to give a little better visual context. Then, a quick check of the motion study confirms that everything is moving as it should.
So, not only can we communicate in real time, we can collaborate on the same design. And I get to ask that a lot in SOLIDWORKS is, what if I wanted 2 people working on the same design at the same time? The other part of that I want you to think about is the fact that all the data is stored on the cloud and it's accessible by everybody all the time. So as soon as you saw that he added the support members, it was accessible by the other user. I didn't have to go to a server. I didn't have to go to a location. It was always available. So I don't need to concentrate on managing the files. And we talked about the concept of being connected. That's where that comes into play. Now, our last part of our process is to refine the design even further. We're not ready to present it back to the customer as a complete digital mock-up. I need to add some off-the-shelf components, things like brackets, springs, casters, cylinders. I have a lot of 3D data on our network. I just need an easy way to find it. Also, I want to keep my existing motion study as I make modifications to the product in order to validate the mechanism works as I add more detail.
To finish out the conceptual design, we may need to insert some existing or purchased parts. We should be able to reuse the barrel clamping mechanism from a previous design. I'll hide out some of these components to get a clearer view. From the search tool, I just enter a keyword, and any data matching that description shows in the results window. Now we can just drag and drop these parts into the assembly. The Automate tool in Mechanical Conceptual instinctively predicts how parts should fit together. As I select on one of the holes in the bracket, then hover over the mounting post, the software shows me several possible mating locations. Selecting on one of the on-screen handles gives me a preview of the different possible orientations. A parallel mate will then make sure that the bracket stays fixed with respect to the post. Now to attach the gripper clamp. Once again, the Automate tool predicts how it should mate up with the bracket. I just hover over the preview until I find the desired orientation. Dragging the clamp, I have the proper range of motion, but as I look at a top view, it looks like the clamp is not wide enough to fit around the 55-gallon barrel. I'd prefer not to rebuild this part, and I'm not sure how it was constructed in the first place. However, the direct editing features in Mechanical Conceptual make it easy to modify this part. If I could just bend the arm outward a little, it would fit just fine, and that's basically what I'm able to do with direct editing. Once I select a few faces, the on-screen handles allow me to drag, push, pull, rotate, or offset the existing part geometry without any regard for how they were initially modeled. This means I can quickly reuse and edit existing 3D data without having to be a CAD expert. I need some way of maintaining tension between the clamp and the barrel. With built-in mechanical features like 3D threads and real working springs, it's easy to add mechanical function to my conceptual design. From the built-in spring library, I just specify the free length, spring rate, size, and material. The legs on the original lifter frame are not quite long enough. Once again, direct editing makes this a breeze. I just pick on the end faces of the legs and use the handles to drag the length. The on-screen rulers help me lock in a precise dimension value. We used some off-the-shelf casters in the original design, but I've got them hidden for now. I'll use the search tool to find them in the existing assembly. They're automatically selected for me in the design tree, so I can show them all at once. I'm thinking about using a hydraulic cylinder to actuate the lifting mechanism. I should be able to find one on the 3D Content Central website. This looks like the right one. I can configure and download this right into my existing assembly in Mechanical Conceptual. Fast forward a little, I've already got the cylinder positioned and made it into place and set to flexible. The last thing to do is verify the motion in 3D. That same 2D motion study we set up from the initial concept sketch is still working for us. We can see the trace paths, and now we can even show a volume sweep to visualize the complete motion envelope in 3D. We were sure able to do a lot of work in a short amount of time to verify this concept prior to launching into a detailed design.
So when you look at the search tools to find data, because you don't have to think about where things are stored, you're constantly connected to the data, it allows you to get to the data using a variety of methods. The other thing there is the direct editing techniques. There really is a different way of doing direct editing. If you need to see a little bit more of this product, and we could certainly go more into direct editing, but it doesn't destroy the feature history of a part. It changes it so you can make some edits, but allows you still have that feature history. That is important still. The final step is to allow me to present my concept back to my customer, right, with all the details mocked up so the entire idea is illustrated. I have a 3D model. We go from here, we can export this out, pull it into SolidWorks, finalize the details of the design, and create our detailed drawings. So what did we kind of go through today? We learned that we can quickly evaluate ideas with a tool that's like your digital notebook. We captured the conversations with a cloud-based See What You Mean swim community. It's like a virtual design review that's always accessible. We designed and evaluated motion without CAD rules, product data that's always secure and accessible, and we have a better launch pad for a detailed production-ready design. Now, Tim Brown, President and CEO of IDEO, had this to say: prototypes should only command as much time, effort, and investment as are needed to generate useful feedback to evolve an idea. Think about that. In the early part of a project, we don't want to use the same tools that we're using to get a design ready for manufacturing. We need a set of tools like SolidWorks Conceptual Designer that's conceptual, instinctive, social, and connected. When we look at our 55-gallon lift and tilt project, we need to be confident our detailed design work and manufacturing documentation efforts will be invested in the best design. We saved a lot of time by re-enabling designers to communicate and collaborate as they conceptualize ideas. Okay, here are just a few examples, testimonials of customers using Conceptual Designer. Now, there has been a name change. This was called Mechanical Conceptual, so you'll hear them use that term, but SolidWorks Conceptual Designer is the same tool.
SolidWorks Mechanical Conceptual, it's that creative piece that really flows well between, hey, I got this idea, the customer wants this, all the way through, here's what you're going to get, Mr. Customer, it's on the truck, it'll be there tomorrow.
SolidWorks Mechanical Conceptual will help us to bring the new innovations to the market in the fast way we have to do, because that's really important in our business, to be one step ahead before our competitors.
Mechanical Conceptuals very, very helpful for us to bring our products faster to market. Very easy way to simulate a product and validate the product, and so it helps us to bring the product quicker to manufacturing area.
So just to kind of wrap up the conceptual designer piece, and then I want to review some of the technology real quick to kind of have you take back to your groups as an understanding of what big pieces there are there. Things that we want to focus on is the ability to design faster in the conceptual phase, explore more of those ideas, capture that archive, improve your collaboration between your stakeholders, and realistically just enable innovation. If you can move faster, if you can put more ideas on digitally, you can make more decisions a lot quicker. So Conceptual Designer, we just kind of saw a bunch of different areas in which it could be used, but I wanted to kind of outline some specific areas that I want you to kind of take back with you. And I've kind of focused these on the individual pillars of Conceptual Designer, the idea that we have a conceptual product. First of all is the ability to create mechanisms. There's lots of tools built into this product that are very specific to mechanism design, where we're not sketching out things like linkages. There's actually a linkage feature within the tool, and it allows you to do things like this. Very easily connect multiple linkages, see the motion, make the changes, all in 2D. So mechanisms is a huge focus of Conceptual Designer. We have this idea of 2D motion. You see the arrow showing that we're driving the motion through that linkage. It's like SolidWorks motion, where we can actually see how something's going to work by driving it physically. But we can do that in both 2D and 3D. So 2D models, 3D models are combinations of both of those. Okay. This whole idea of concept archives, it's a very important part of the conceptual process, because you take so many twists and turns. Oh, what if we did this? What if we changed the length of this? What if we tried a completely different product? The conceptual archives is the important part, where you can go back and retrieve any variation. This is just a quick video example of the ability to retrieve multiple variations of a design. And you know, you make so many decisions in this R&D phase, it allows you to go back and forth a lot faster. Let's talk about the instinctive nature of Conceptual Designer. First of all, it doesn't come across as much in our project, but the whole idea of a single modeling environment, you know, SolidWorks, we have parts, assemblies, drawings. Here, we don't have to worry about if we're in one versus the other. Okay, it's a single environment. And you saw that with the mechanism, but it's really amazing how this works, that you can have motion in 2D and 3D, and you know, you're creating parts on the fly. I mean, you could create 10, 12 parts in the matter of seconds from a single sketch in this case, just by grabbing a handle and saying, hey, this is something I want to turn into 3D. This single modeling environment is amazing. Okay, it just eliminates that thought process that we typically have. Okay. The real features, you got to see a little bit of the real features in the presentation, but here's another example, threads. thread libraries, actually having models that are light enough and are fast enough without all the design constraints. And then you saw the whole idea with springs, a spring library of working springs. Okay, it's instinctive. It allows you to see what happens in the real world. Direct editing is amazing. With this direct editing tool that's built into Conceptual Designer, it allows you to take something that we would typically have with a feature tree where you built with features like a hole, a boss, and actually convert it to something you can direct edit. But what it doesn't do is destroy the feature tree. Okay, which is, we have competition from our other vendors on this, and when you go to direct edit mode on parts, you destroy the history in a majority of cases. Conceptual Designer, the direct editing is amazing. So I encourage you, if you have parts that maybe are imported and you need ways of modifying and changing them, direct editing and Conceptual Designer will help you. The social aspect of Conceptual Designer, the idea that everyone is connected to the same set of real-time data. You can go through and see other people's designs, see other people's parts, grab the part out of their design and place it in your design. What you're seeing in the video is just an example of a search where it looked at the project structure and you're able to add it to your existing design using mates. So in the typical process, you have to wait for somebody to save it or to move it to the server. Because everything is real time, you'll see all the data in real time as well. Messaging, the whole idea of just communication, the ability to review products and files real time, just provides another level of social collaboration on products. So this becomes an important piece to the conceptual phase, and there's just another quick example that you can kind of take back with you. Communities, and hopefully it came across in the messaging, but the whole idea of having a community that you can go to talk about the product, getting other stakeholders involved. But can you imagine opening this on your cell phone, on your tablet, no matter where you are? I mean, we even have web-enabled TVs now. I mean, you could be at home sitting on your couch with the remote control, surfing through your community and responding to blog posts and questions about a design. It's kind of an unprecedented way of communicating. The idea of being connected. Now, we didn't talk a lot about the cloud in this case, but keep in mind this: the cloud is in reality your own area, your own cloud. Now, you saw me jump into my swim community. Well, that's specific to CAD Dimensions. That's our own cloud area that we store data. So the cloud is for your organization. It's where you store your data. Nobody else can get access to it, but you have the ability to find anything you need using a lot of different variations. In this case, the search on bracket, you can find the bracket and place it into your design very easily just by doing a search. The idea of a collaborative space. Now, we talked about that you're saving stuff to a cloud, but we also create spaces within the cloud. We say that, okay, here's a space for this concept. It's almost like a folder in Windows, but there's no folders on the cloud. It's just an area where all the data resides. Those spaces, you can invite people to contribute or to edit content. You add members to the spaces, so only those people can save data to your space. Okay? And then we mentioned this, the access from anywhere. Here's a video of getting into a swim community on a Samsung Galaxy phone. It really is access from anywhere. Okay? And to finalize my presentation today, I want to talk about another piece that's part of this, and we mentioned this at the beginning. This is the simulation. On top of this, there's another app called PDS, or Product Design Simulation, that gives us simulation capabilities from Simulia. And you're just seeing a quick example of creating a bolted condition between two plates. And this is all done on the 3D Experience platform. We apply a pressure, we apply the bolts, and we're able to analyze and see what this looks like all out in the cloud, real time, with all these things that we just introduced. Okay, so there's a quick example. So I want to thank everyone for coming today. If you have any questions beyond what I've shown, please post them in the question section. Otherwise, you can reach me at kevin@caddimensions.com. I hope you enjoyed at least an insight into 3D Experience and SOLIDWORKS Conceptual Designer. There is a tool that was announced at SOLIDWORKS World this year called SOLIDWORKS Industrial Designer that should be out very, very soon. Again, that's just another app that's going to run on the 3D Experience platform. And by the looks of it, there's going to be many more apps coming down the pipe. So, hopefully we can help you understand what 3D Experience means and what each of these apps is going to